Hi, my name is Dawson Jones, and I'm working with Garrett Hunter on our EMEC 403 project. Today we'll be working with SolidWorks Plastics. SolidWorks Plastics is a simulation tool used to analyze plastic parts and injection molding. In this project, we'll be going over the plastic simulation of a part for a capstone project. The part being demonstrated is a housing for a velocity sensor used in that project. The sensor housing isn't for sure going to be plastic injection molded, but we would like to go over the process if the part were to be. So this is the part that we're going to be using for this project. As you can see, it doesn't seem like a good part to be injection molded due to these sharp edges around it. So obviously this will need to be filleted and more rounded out before being molded. We first want to just use this part to determine how well this would actually work with the injection process, how bad it's going to be, and how we can fix it to make it a better part. So with these sharp edges, they create a lot of stress concentration in each part, and there are a lot of different corners and sharp edges. Also, this thin design is actually good for it, causing not a lot of sink marks. The injection has a good pressure throughout, and we'll show that later in the SolidWorks Plastics simulation. So as of now, we've created a pretty simple mesh. We didn't really refine it around the corners. We just made it even throughout our part, and we also added an injection point at this point. We don't know exactly the right spot to inject it, and we decided one spot's better for maybe less weld lines going throughout. Weld lines are created when two different flows meet each other when they have a cooler flow, and they just create a line in between where they connect. These aren't good for the structure of the part, so we decided just maybe one, and if that doesn't work, we'll move it to two. So shown here are the results of the simulation that we just did with SolidWorks Plastics on this part. As you can see, it didn't really like these edges right here. It's red, very quick fill time. There's some spots right here. It's called a short shot, when not all of the plastic froze before it could reach all these parts, these gray parts right here. This obviously isn't good because it's not going to create the whole part. There's some different stuff we can look at. There's some shear stress. Obviously the stress built up in these edges over here. And there's one, the volumetric shrinkage, which shows the shrinkage of the part, which was actually pretty good through the part. A little bit in these big faces, but pretty good because of the thinness of the part. We can actually show you how this ran and just show how it went through the part. So obviously it didn't like those parts over there, as I said earlier, but it filled pretty well around the other edges. Not a lot of problems, but I think we can make it better, and we'll definitely fill up these parts, these edges, make it a little better for this injection mold, and we'll do this simulation once again.
So initially looking at this part, there's a few errors in our original design that will cause it to flow bad. It could potentially break the part when removing it from the molding. It's just overall not a optimized part. So after researching how to make a better part for plastic injection molding, we came up with a few conclusions. The first conclusion being that the sides need to be drafted. And so we put a slight 2-degree angle draft from this top face to these sides. And initially the plastic is heated very hot and then is cooled once it flows through the part and as the results are done. And this cooling makes the part shrink. And while it shrinks, having this slight angle will reduce friction and wear along the sides. And so it'll make the part come out cleaner. It'll make it so it's less likely to break, and overall it's just useful to have. And second conclusion that we came up with is that we need to fillet all these sharp edges. So as seen in this original design, there was sharp edges almost on every place. And so essentially for the plastic, even the very hot molten plastic, it needs a very high pressure to flow into these edges. And this makes it extremely hard to create a good mold and to come out with a good piece. And so what we did is we filleted every single edge that we could. These bottom slots were problem location in the first video. We had to leave that unfilleted just because those slots are meant to connect into a track. So we could not fillet these parts without ruining the part. But everything else we fixed with fillets and made smooth curved edges, which will hopefully allow the plastic to flow better inside the molding, and it will create a better part and flow quicker.
So meshing this piece, we used the same triangle size throughout this part, except we did need to add a mesh tolerance around the fillets just to keep the fillets. If the mesh tolerance is too big, or if you just keep the same triangle size, it kind of cancels out the fillets and makes them useless. So we did need to add a little tolerance in there. It does look pretty good around these edges. It just shows the nice smooth corners, and we'll be able to do a simulation on this a lot better than the first part. Okay, so this is the results of the simulation on the new optimized part. As you can see, it seems to flow around these faces a lot better. It seems to go around these corners and flow right, you know. But as we look towards the front, still a lot of problems with these short shots in here. Even more space wasn't filled with the plastic. This might be because of maybe the heat of the plastic. Definitely this little piece needs to be fixed if it were to be injection molded. This isn't the best, but overall the rest of the part does get a good flow through it and a good fill time, I guess. We can look at volumetric shrinkage. So around the back and these faces, it seems to have gotten a lot better. This corner and this face seem to have been affected pretty bad compared to the first part. Not sure why that is. And maybe just look at the shear stress. So shear stress is definitely a lot better than previous. Still only in these little flanges, but overall not a lot of stress. Looks like it worked pretty well. And so with that, thank you guys for tuning into this video in our Lab 11, and see you later.